Le doy la bienvenida entonces a el nuevo equipo de disertantes. Adelante. One, two, three, four. 4. Bien, con 3 micrófonos estamos bien.
Hello. Hi, my name is Sebastian Wine. I am the moderator of this panel where we will talk with 3 experts about decentralized storage. Hi guys. Could you please introduce a little bit about what you are working in this field? Okay, what projects, and we can talk from there.
Yeah, sure. So my name is Rinke Hendriksen, and I'm working on a project called Swarm. Swarm, is a project for decentralized storage, right? I think Swarm is rather unique in the sphere. That's like you can really upload something to the Swarm, and once you upload it, you have no control whatsoever anymore as to where those little pieces that belong to this file end up to. So it's a project for a decentralized, censorship-resistant store of information, basically.
Hello, I'm Adam Uhlir. I am contributor of a JavaScript implementation of IPFS. And IPFS, neboli Interplanetary File System, is a project of protocol labs that have similar goals to Swarm. So it's a decentralized storage system which allows to distribute content around the network.
Hi, my name is Vojtech, and I'm part of RIF storage. RIF storage is actually not a storage system itself, but it's a protocol that is enabling users access to third-party storage systems, like Swarm or like IPFS, but it's fully open for any third party to actually integrate.
Well, the first question is, why do we need a blockchain for distributed storage? Because in the past we have protocols like BitTorrent where they never use a blockchain. So the question is, why do we need that?
So I would say that even BitTorrent had some sort of incentives, had actually a monetary value where it needed blockchain. This value was actually reputation. Right now, what we're adding is actually the incentives which needs blockchain. So you actually need to have some sort of intrinsic value that you give to the participants of the network, and to maintain the network, to make sure that there's no bad actors in the network.
Yeah, I would just maybe add that, for example, from IPFS perspective, there is no really need, or on its IPFS layer, there is no blockchain in the game. It's only when you actually start to deal with availability of the data that exactly some incentivization that the blockchain comes into the game. And for example, in IPFS perspective, that comes the Filecoin project that Protocol Labs is also developing.
Yeah, and I think I can add that within Swarm, incentives always has been like an integral part of the core vision of Swarm. And we need incentives, especially because it's a decentralized network of peers whom basically nobody controls, right? Swarm maybe 1,000 or 1 million of nodes in the future, and these nodes, they run software, which right now Swarm is developing, but also later on, just as in Ethereum and Bitcoin, there might be other clients. And basically, we need those incentives for the nodes not to have any incentive to modify the behavior of their nodes. So Swarm really tries to add incentives, positive incentives and negative incentives that actually makes the behavior of the node, of the software, reasonable. So there's no incentive at all to kind of adjust the code of your node. Because if you do this, then you will make less profit, and you might also risk losing money, which is at stake. So I think incentives, and therefore also blockchain, right? Because we do the incentive, we do the payments with blockchain, because blockchain allows you to do micro payments, you can make smart contracts, you can make second layer payments. And I think for this, like, you cannot do this with Visa or with PayPal at all. You need a cryptocurrency to program the incentives in a way that makes sense.
Okay, one of the concerns about distributed storage is about durability, okay, and losing your information. Because, for example, if you contract a service like Google Photos, you know that you can blame Google, and there are ways to sue them if they lose the information. How can you handle durability in these distributed storage systems?
So just so I'm sure I understand the question, in durability you mean like persistence of the information?
Yes, it's persistence.
Okay.
Persistence and responsibility,
And
okay, for that information, basically.
So basically some sort of agreement between the storers and between the users.
Yes, that's right.
Basically the idea of decentralized storage is to not have such relationship. It's similar to blockchain, where you don't actually want to trust the individuals in the network, but you want to make sure, and we talked about incentives in the previous question, you want to make sure that they are incentivized to obey by some rules, and they have incentives to not leak your information or not lose your information. So that's very critical, I would say. Durability is very tough in decentralized storage. It's very tough to actually prove that a file is stored. And it's something that we've been tackling for quite some time. IPFS and Filecoin has been tackling it for 3 years now, 4 years now. The way you ensure that your data does not leak is to encrypt it. And the way you ensure that it doesn't get lost is you need to incentivize the network, either providing stamping some value directly on the data, or making sure that there is some centralizing component that is giving you this guarantee. But the storage, as I understand it, is actually infrastructure. All this kind of agreement of storing and persisting certain files is a layer on top of that.
Yeah, so I think our Swarm makes sure that your data, like, kind of long-term stays on the network. It's what I already said is by providing incentives, but also by the protocol. So when I'm uploading a file to the Swarm network, what happens? It gets chunked into many pieces, and those pieces, they travel around in the network. So the file itself, it is not at one node, it's actually at all the nodes in the network. And every chunk has a certain level of duplication. So that means that, let's say by random, 10% of the nodes of the network go offline, then I can still most likely request my file. But if a certain threshold more of the nodes go offline, then I'm obviously having a problem. And I think this is really why this durability is such a hard question in decentralized storage, is because we really don't have that much control over all the nodes in our network. It's not there yet, but what Swarm aims to do is to have what we say kind of insurance scheme, so you can, with certain providers, make insurance for your chunks, that your chunks will stay online. And if we have this, well, you still don't have the hard guarantee, but at least you have the guarantee that if you have an insurance scheme for a chunk being available, and it's not available and you can prove this, then the store gets slashed and you might get maybe part of what you paid for this chunk to be stored, you get it back maybe.
Yeah, I would just add from IPFS perspective, I quite often see that people get this image of IPFS as like a magic network, that you add something to it and it will be stored there forever and ever. But that doesn't really work that way. You exactly, like in IPFS perspective, you actually have to sort of pin the file on some node, so it's available. And if it's not, then it's not reachable. Then the Filecoin project builds on top of that, sort of to bring exactly this second layer of marketplace where you can ask for somebody to store your file for some price, and there are some guarantees or let's say collaterals that you would lose if you would misbehave and so on.
And do you think these markets will be in place in short time? What's your vision now? Just guessing.
Well, from Filecoin perspective, they are running testnet, but I don't really know when they have, if there is any really close sort of timeline for any mainnet idea. Not sure.
Yeah, so on the RIF storage perspective, we're actually launching some form of incentives this month. But the incentivized persistent storage will happen in the first quarter or second quarter of next year, and the fully incentivized network within a year.
So, obviously, if you need to store files in a distributed storage, you need space, okay? And the space needs users, and users need to obviously buy hard drives or SSDs, whatever. Do you know, or what is the overall capacity of this distributed storage? Okay, is there a metric? Is there an idea of how much information can you put there?
Yeah, so as Filecoin is not really launched yet, so there is no real known like capacity there. From IPS perspective, there is quite big adoption from universities who use it to manage like large data sets. But some exact data I'm not really aware of, because that's sort of a treat of decentralized networks. It's sort of hard to track these things. And for example, like IPFS tackled this sort of with opt-in model that you can like allow to be tracked, sort of. But so it's very hard to guess what's the real capacity. I don't know.
But I imagine that there, sorry to interrupt you before you continue, but I think there is like a middle ground where some companies can be interested in putting resources for storage services, okay? So you have the best of both worlds. I don't know. What do you think?
I'm not sure if I got your...
Yes, what I'm saying is like, if you don't have enough storage, there can be companies who spend money on building huge data centers like the cloud services, but using this protocol instead of a centralized one. Is this possible? Is this possible, basically?
Yeah. So there is no real like limit where it can grow to. Then there might be some, let's say, performance issues when, for example, the DHT layer becomes sort of very hard to manage or hard to actually perform. But I'm not really sure where are the limits there.
So I would, again, circle back to the incentives because it's all market, it's all open market. So if there's a shortage of a resource, it means that prices of storage will go up, which will incentivize more and more providers, storage providers, to join the network and increase the capacity. In Swarm and IPFS, as far as I know, it's quite difficult to measure the actual size of the network. There are some ways. In IPFS, there is optional reporting of this usage, but that also just means that the users needs to be trusted that they report the right capacities. In Swarm, you can deduce it a little bit by looking at how big the network is and assume that all the peers in the network will have a certain capacity. But there are projects like Saya, which actually is a bit more centralized, that is directly, where you can actually directly see the size of the network. And this one has right now around 2 or 3 petabytes of storage. Yeah.
Okay, perfect. I think one of the concern for users and for companies in cloud storage is about price. In general, the cloud storage is very expensive. Okay, it's more expensive than the computational part. So, do you think that the price of distributed storage will be much less than the centralized option, or do you have some idea of the price of this distributed storage versus the cloud storage?
So, I think it's good to realize that all of the projects here, IPFS and Swarm and RIF storage, like, we're not yet live with an incentivized network. So to say whether we are right now cheaper or more expensive than Amazon is, like, I cannot answer this question, but I can of course reason about what I think will happen. And I think very crucial is to realize is that, like, I guess everybody here in the room, like, you have probably a computer with maybe 100 gigabytes of data which is not used, right? And what is the idea is that all of you can hook on your computer to this network. And when you're having your computer open, you just give maybe 50 gigabytes to Swarm or maybe to IPFS. I'm not sure how that will work. And, like, I guess you'll be doing it for rather cheap, right? Because anyways, this data is not used, so you'll be happy to have anything more than 0. So if you take all of the unused hard drive space in the world, I think until that capacity is filled, we are pretty far ahead. And until this capacity has been reached, I think we can be cheaper than the centralized components like Amazon and Google, who actually have to set up dedicated servers to run your stuff. But you can just do it, and it will not cost you anything extra apart from maybe a bit more electricity. But it's really little compared to how much electricity mining would cost, for example.
So I would actually challenge that statement. I would say that anything decentralized is always less optimal than centralized system. It's just usually more resilient. And just a matter of actually storing stuff decentralized brings in a lot of unnecessary overhead. And this overhead has to appear somewhere. So if you look at providers like Amazon, they optimize their storage and they know what they're doing to minimize their cost. If you're running anything decentralized, you cannot really do that. It's like building stuff in a company like cars, where you have specific machines that just do one thing, and you can actually buy exactly the right amount of material for just that one thing. Whereas if you customize it a little bit, then you have a lot of waste. So I see it this way.
Yeah, I would just add that the price is definitely important, but there are also other aspects. If we really want to build like decentralized ecosystem, then decentralized storage is important from just as a building block for the decentralized applications, right? If you want to have some amazing app that you would be serving with over normal HTTP, that doesn't really serve the purpose we are trying to achieve here. So definitely for the long term, the price will be important, but I feel now at the current state we are in, it's actually more of another building block that's important to have.
Oh, that's great. And I am curious about the use of distributed storage for handling media. Like, can we think about new Netflix or new streaming services that use this distributed storage, and how the throughput and latency will work on that? What's your idea?
So I would say that throughput and latency is something that we're not so sure right now, but the estimations are that it could be better than a centralized system, mostly in solutions like Swarm, for example, where you're not only having decentralized storage, but actually you're getting for free a content delivery network. So if your content becomes popular, you don't actually have to go and purchase additional servers around the world to serve this content faster and to not have a distributed DOS attack basically on your one server. Swarm does this automatically on you, for you. I'm not so quite sure how it works with IPFS, but
yes, similar. As more the content becomes popular, the more there is more providers in the network for it. So yes, it works the same.
They need to actively say that they want to save this file and also provide it, right? It doesn't come automatically with the protocol.
Not in the way Swarm, how Swarm works, but if a user downloads a file from IPFS network, he becomes also the provider of that file, maybe just for a short period of time, but in that time, he also helps it to distribute it in the network.
Okay. And if users or companies want to use this software, they just go to, I don't know, to GitHub, download it and try it, or they need to take care of something special, how they can start using this from scratch?
So I think at the moment, given the maturity of the projects at the moment, I would not recommend just going to GitHub and run your solution. I would really advise you to reach out to people who are actually working on the projects and try together with them to figure out whether, one, your solution actually makes sense on a decentralized protocol, and two, also to get support from them, because at least Swarm, we are really looking for people who are actually building their application on our platforms. So if you're interested in that, sure, reach out and you'll get a lot of support from us, I'm sure.
Yeah, I would say it's a bit easier on the IPFS side because it's been like IPFS has been with us for a while. It got a lot of attention, so there is a lot of material on the internet, a lot of articles. They are improving a lot in the documentations page. There is several implementation, many client libraries you can use. Pretty much the range is wide.
Yeah, and I would just mention that on the RIF storage and to start a network, you actually would have to first use or start the nodes of Swarm or of IPFS or of any third party. There are some nice solutions which are pretty much just one-click start. And I think that's something that all the storage systems need to actually have adoption.
And do you have like a 99% availability like Amazon? I think it's more, it has more defenses against problems in the sense that, for example, if the network connection of an Amazon or Azure or Cloud or Google Cloud node went down, like you don't have an option. You need to wait, basically. I assume that because this is distributed around different regions, you are more protected against these kind of failures. Is that right, or?
Yeah, when it comes to SLAs, it's kind of different state in this sort of area. We already talked about the responsibility of the content and serving, right? So that's sort of related to that. The advantage of these systems is mainly the decentralized part, right? Because even well, by its nature, the cloud providers are quite centralized, even though they have hubs all around the world. So they can guarantee that their uptime locally, but they cannot really do anything about the network side. If some IPS internet provider like goes down, then still the end users are not served the data. With these decentralized storage systems, it's by its nature, it's much more resilient to these sort of problems.
And just to add to that, I think it's important to realize that you cannot have an SLA with an infinite number of nodes whom you don't control, right? You cannot have a certain agreement with a network. But what you can have, and what we actually also using in Swarm, is smart contracts. So in smart contracts, you can program certain actions happening when something else has happened. So we have this notion of slashing. So what I already said, you can have insurance agreements with certain nodes, and if you can prove with cryptography that those nodes don't behave in the way they should behave, the smart contract can actually execute and you will get part of your money back. So such agreements are kind of possible, but they are a whole different beast than if you would make an agreement like this with Amazon.
I would just return to the original question and say that it's by definition, decentralized storage should be much more resilient, because you actually usually have just a protocol with a set of implementations. So even if there is some sort of error in one of the implementations, it should not take down the whole network, similarly to how Bitcoin or Ethereum is run. And unlike, I would say, centralized providers similar to AWS, decentralized storage can run on all sorts of networks, like mesh network. It's a protocol that basically can utilize any connection most of the times.
Perfect. And the question about censorship, okay? Because I think it's good to have a distributed storage to be protected against censorship, okay? It is something that some social organizations are thinking of. What's happening in that area? I think we are short of time, but we can do like a quick question and answer.
Yeah, I mean, this is super important, right? Because the censorship resistance part is essential to why we need decentralized storage. And I think you actually touched a very interesting point with regards to mesh networks, but the lights go off, so.
This is why we're building it, for the censorship resistance.
Yeah, I would just add that there were already some use cases of IPFS which was deployed exactly for this cases in Catalonia referendum and with Turkey Wikipedia blocking. So it's happening.
Okay, that's great. Thank you, guys. Thank you very much.